My name is Miriamxyra. Welcome to my ethical hacking tutorial about buffer overflow. This video is intended to security researchers and IT professionals who want to learn more about IT security. Please do not use this video to violate the law. Thank you. In this tutorial, I will talk about buffer overflow. How does it work and what can you do as a programmer to avoid it and to write safe code? Buffer overflow is the consequence of a vulnerability in computer software. It crashes your application and a potential attacker can use it to inject malicious code, the so-called payload. In many programming languages, it is up to the programmer to secure the code and to limit the memory usage.
To understand how buffer overflow works, you have to know how data is processed in the stack. Let's have a look on the processor registers. There are 8 general registers and 2 special registers. In this video, I will explain only those registers needed to understand buffer overflow. As there are the extended stack pointer, the ESP, which points to the top on the stack. The base address of the stack is located in the EBP, the extended base pointer. You can find the stack area between those 2 pointers. There is also a read-only special register, which is called the extended instruction pointer, the EIP. It contains the address of the next instruction and points to the memory segment of the program code. Let's take a closer look at the stack. In this slide you can see the stack area. The ESP marks the top and the EBP points to the base. While the stack is filled in the direction to the ESP, a stored string grows into the direction of the EBP. Next to the EBP, you can find the return address of the program or subfunction. This address contains the address of the storage to jump to after the function finishes. This code will be executed next. So, when there is no bounds checking enabled, and the string grows further than the buffer reserved for the string, the buffer is overwritten. If the string is long enough, the EBP and the return address are overwritten as well. A buffer overflow occurs. The value of the return address is loaded into the EIP. If it contains a value that makes no sense, the EIP doesn't find the program code which should be executed next, and so the program crashes. To demonstrate how this works, I have prepared a little program in my lab. It waits for the user input and writes it to the variable text with the unsecure function gets. This function has no bounds checking implemented. After the insertion, it shows the input to the user and closes itself. As I have 4 characters reserved in the buffer, nothing happens when I get prompted and I insert 4 characters. The program terminates itself in a normal way. When I insert 15 characters, nothing happens as well, but you can see that the whole string was stored in the stack. But when I insert 16 characters, The program stops working because a buffer overflow was triggered. Let's have a closer look at the immunity debugger. As you can see, between the ESP and the EBP lies only a small area in which the variables are written to. 4 bytes after the EBP, you can find the return address, which will be loaded into the EIP to be executed next. You can see the value of the EIP here. So what happens when a very long string is written to the stack? You can see that my string was written into the buffer, and since it was too long for the reserved space, the value of the EBP was overwritten with 4 Ds. The return address was overwritten with 4 E's, which is equivalent to the value 45454545. The EIP has the same value since the return address contains the address which should be executed next. But since there is no code with this memory address, the program crashes. But what happens if you override the return address with an address that makes sense? The only address that makes sense for an attacker is the address of the ESP, the top of the stack. If an attacker finds out at which address the stack begins, he can easily exploit the program. As a first step, he inserts malicious code into the stack which cannot be executed yet. If he is able to override the return address with the address which points to the ESP, this address will be loaded into the EIP. Since the address which is loaded into the EIP points to the code which is executed next, the malicious code will be executed. The exploit was created.
So, as a programmer, what can you do to avoid buffer overflow in your code? First of all, do not use insecure functions with no bounds checking. Use safe libraries instead. If you are allowed to choose your programming language, use a language which has bounds checking implemented. Use C# instead of C or C++. Many compilers are able to check your code before compiling it. Choose a compiler to fit your needs best. There is also the possibility to check your code with tools like buffer overrun detection or Nessus before releasing it to the World Wide Web. On the website of the Open Web Application Security Project, you can find many more tools. If you liked my tutorial, please give me a thumbs up and subscribe to my channel. You will find other interesting stuff on my blog. Thank you for watching.